Hi, hello everyone, and welcome back to my YouTube channel Spotify Learn. Today I'm here with the video of again most important video, that is on DDCO second module. We will discuss without further wasting time. I'm getting comments like ma'am explaining Kannada, a few members will say, explain in English, a few members will say. So I have thought the video to do such as I'll be explaining both in mix as Kannada as well as English, so that both language students can cover up the video. If you are watching the full video, you will get the idea about all the concepts that come under this module. So don't skip the video anywhere. If you're watching my channel without subscribing, make sure to subscribe and then watch the video. Let's start without further delay. And I have got a huge response for the DDCO first module which have been uploaded, and I hope so for the same for the second module also. Come, let's discuss the second module without further delay. Okay, see what they have asked. First question ಏನು ಕೇಳಿದ್ದಾರೆ ಅಂತಂದ್ರೆ, explain the working of 4-bit adder using full adder. Okay, now we have to use this full adder. Okay, and you have to construct a 4-bit adders. How you can do? See, here there is one full adder, there is one full adder, there is one full adder, and there is one full adder. How many are there? 1 2 3 4. Okay, you name it as S1, S2, S3 and S4, and you can see that has been connected to A3, A2, A1 and A0, B3, B2, B1 and B0, and that has been connected from here, that is C0, and it is connected through C1. This is about the construction of 4-bit adder. 4-bit adder. ಓಕೆನಾ, ಇದು 4-bit adderನ ಕನ್ಸ್ಟ್ರಕ್ಷನ್ನು ಸೇಮ್ ಮೆಥಡ್. ಇದನ್ನು ಮತ್ತೆ ನಾನು ಕನ್ನಡದಲ್ಲಿ ರಿಪೀಟ್ ಮಾಡಲ್ಲ. ಓಕೆ, ಇದನ್ನು ನಾವು ಮತ್ತೆ ಏನಂತ ಕರಿತೀವಿ ಅಂದರೆ, ವಿಲ್ ಕಾಲ್ ಇಟ್ ಆಸ್ ಅಗೇನ್ ಬೈನರಿ ಆ್ಯಡರ್ ಅಂತಲೂ ಕೂಡ ಕರಿತೀವಿ. ಅದು ಏನಂತಂದರೆ ಡಿಜಿಟಲ್ ಕಾಂಬಿನೇಷನಲ್ ಸರ್ಕ್ಯೂಟ್ ದಟ್ ಪರ್ಫಾರ್ಮ್ಸ್ ಅರ್ಥಮೆಟಿಕ್ ಅಡಿಷನ್ ಆಫ್ ಟು 4-bit ಬೈನರಿ ನಂಬರ್ಸ್. ಇವಾಗ ನಮಗೆ ಏನು ಬೇಕಂತಂದರೆ, ಅವರು ಏನು ಕೇಳಿದ್ದಾರೆ ಅಂತಂದರೆ 4-bit ಆ್ಯಡರ್ ಅಲ್ವಾ, ನಾವು 2 ಇಂದ ಆ್ಯಡ್ ಮಾಡಿದ್ರೆ 2 + 2 ಏನು ಬಂತು, 4 ಬರುತ್ತೆ. ಸೊ ದಟ್ ಈಸ್ ವೈ ದೇ ಆರ್ ಸೇಯಿಂಗ್ ಹಿಯರ್. ನಾವು ದೇ ಕ್ಯಾನ್ ಸೇ ದಟ್ ಇಟ್ ಕ್ಯಾನ್ ಬಿ ಕನ್ಸ್ಟ್ರಕ್ಟೆಡ್ ಯೂಸಿಂಗ್ 4 full adder ಆಲ್ಸೋ. ದಟ್ ಮೀನ್ಸ್ ಇನ್ ಕ್ಯಾಸ್ಕೇಡ್ ಮೋಡ್. ಓಕೆ, next is where the carry output of each full adder is connected to the carry input of the next full adder. See, if one full adder is there, that is the input will be the, see now I'll explain in Kannada. ಓಕೆನಾ, ಇವಾಗ ನಮಗೆ ಒಂದು ಕ್ಯಾರಿ ಔಟ್ಪುಟ್ ಆಫ್ ಈಚ್ ಫುಲ್ ಆ್ಯಡರ್, ಇದು ಒಂದು ಫುಲ್ ಆ್ಯಡರ್ ಅಂತ ತೊಗೊಂಡು ಇದ್ರ ಔಟ್ಪುಟ್ನ ತೊಗೊಂಡ್ರೆ ಅದು ಏನಾಗಿರುತ್ತೆ ಅಂತಂದರೆ ನೆಕ್ಸ್ಟ್ ಫುಲ್ ಆ್ಯಡರಿನ ಇನ್ಪುಟ್ ಆಗಿರುತ್ತೆ. ಈ ಔಟ್ಪುಟ್ಟು ನೆಕ್ಸ್ಟಿಗೆ ಏನಾಗಿರುತ್ತೆ, ಇನ್ಪುಟ್ ಆಗಿರುತ್ತೆ. ಐ ಹೋಪ್ ಯು ಅಂಡರ್ಸ್ಟುಡ್. ದ ಫಸ್ಟ್ ಫುಲ್ ಆ್ಯಡರ್ ಔಟ್ಪುಟ್ ವಿಲ್ ಬಿ ದ ಇನ್ಪುಟ್ ಫಾರ್ ದ ನೆಕ್ಸ್ಟ್ ಫುಲ್ ಆ್ಯಡರ್. ಓಕೆನಾ, ನಾವು ನೆಕ್ಸ್ಟ್ ಇಸ್ ಇಂಟರ್ ಕನೆಕ್ಷನ್ಸ್ ಬಿಟ್ವೀನ್ ದೆಮ್ ವಿಲ್ ಬಿ ದೇರ್, ಆ್ಯಂಡ್ ದೆರ್ ವಿಲ್ ಬಿ ರಿಪಲ್, ದಟ್ ಇಸ್ ಇಟ್ ವಿಲ್ ಕ್ಯಾರಿ ದ ರಿಪಲ್, ಆ್ಯಂಡ್ ಯು ಕ್ಯಾನ್ ಸಿ A0, A1, A2 ಆರ್ ದ addend bits here. Addend bits, they are the addend bits. Adu addend bits. So B are the designated, that is from right to left, right, that is from right to left, this direction it is there. Next, where subscript 0 represents the least significant bit, andre subscript 0 ಏನಿರುತ್ತೆ ಅದು least significant bit ಅಂತ ಕರಿತೀವಿ, least significant bit. ಇದೆಲ್ಲ ನೀವು PUC ಲೇ ಓದಿರ್ತೀರಾ ಈ ಕಾನ್ಸೆಪ್ಟ್ಸ್ ಎಲ್ಲ, ಆಯಿತಾ. ನೆಕ್ಸ್ಟ್ ಮತ್ತೆ ಬಂದರೆ, the first full adder adds A0, B0. See, ಇಲ್ಲಿ ಫಸ್ಟ್ ಫುಲ್ ಆ್ಯಡರ್ ವಾಟ್ ಇಟ್ ಹ್ಯಾವ್ ಆ್ಯಡ್ A0 ಮತ್ತು B0, ಆ್ಯಂಡ್ ಇನ್ಪುಟ್ ಕ್ಯಾರಿ ಏನಿದೆ ಇದು ಇನ್ಪುಟ್ ಕ್ಯಾರಿ. ಐ ಸೆಡ್ ರೈಟ್, ಇಟ್ ಇಸ್ ಕಮಿಂಗ್ ಫ್ರಮ್ ಹಿಯರ್ ಟಿಲ್ ಹಿಯರ್, ದಟ್ ಈಸ್ ದ ಇನ್ಪುಟ್ ಕ್ಯಾರಿ. ನೆಕ್ಸ್ಟ್ ಇಸ್ ಸಮ್ as the S0, that is named as S0, S1, S2, S3, and that is the final carry sum, and this is you can write in the theory part. I hope you are clear. Even though I have explained in Kannada and English, I hope you are clear. Okay, now let's discuss about what is latches and the flip-flop differences. Okay, ಈಗ ಟ್ರಿಗರಿಂಗಿಗೆ ಬಂದರೆ ಲ್ಯಾಚ್ ಏನಿರುತ್ತೆ ಅದು ಲೆವೆಲ್ ಟ್ರಿಗರ್ಡ್ ಡಿವೈಸ್. flip-flop is a edge triggered. You can see by the name itself. See, when you say you have to discuss about the in this module only it will come, right? I'll show you the question itself. Edge triggered D flip-flop. ಓಕೆನಾ, ಇದು ಏನಾಗಿರುತ್ತೆ, ಎಡ್ಜ್ ಟ್ರಿಗರ್ಡ್ ಆಗಿರುತ್ತೆ. ಓಕೆನಾ, ಎಡ್ಜ್ ಟ್ರಿಗರ್ಡ್, ಇದು ಲೆವೆಲ್ ಟ್ರಿಗರ್ಡ್. ಯಾವುದು, ಲ್ಯಾಚ್. ಇದರಲ್ಲಿ ಮತ್ತೆ ನೀವು ಕಂಟ್ರೋಲ್ ಸಿಗ್ನಲಿಗೆ ಬಂದರೆ ಇದು ಎನೇಬಲ್ ಸಿಗ್ನಲ್, ಫ್ಲಿಪ್-ಫ್ಲಾಪ್ ಏನಾಗಿರುತ್ತೆ, ಕ್ಲಾಕ್ ಸಿಗ್ನಲ್. ಔಟ್ಪುಟ್ ಅಂತಂದರೆ ಔಟ್ಪುಟ್ ಚೇಂಜಸ್ ಆ್ಯಸ್ ಲಾಂಗ್ ಆಸ್ ದ enable signal remains active. ಇಲ್ಲಿ it changes only the active edges are of the clock pulse. ಮತ್ತು ರಿಲಯಬಿಲಿಟಿ ತೊಗೊಂಡ್ರೆ ನೀವು ಈಗ latches are more prone to glitches and timing problems, where flip-flop provide better timing control and reliability. Design complexity ತೊಗೊಂಡ್ರೆ it have a simple circuit design. Flip-flop are more complex due to additional. ಆಮೇಲೆ latches are mainly used in asynchronous circuits ಮತ್ತು flip-flop synchronous digital ಅಲ್ಲಿ ಯೂಸ್ ಮಾಡಿರ್ತೀವಿ. ನೆಕ್ಸ್ಟ್ ಇವಾಗ I hope you are clear with the difference. Okay na, I'll explain once again. It is level triggered, it is edge triggered. I'm saying first is about latch, next is about flip flop, next it will use only when it is enable signal, and this will be while the clock signal for their operation, and it will require that is output changes as long as the enable signal is active. Here it will be active edge of the clock pulse, it will change. Reliability means it will be more prone to glitches and timing problems. Here it is better timing control and reliability. Here it is simple circuit diagram. Here it is more complex, and that is due to clock circuitry. And the next is about the it is asynchronous circuits, this is synchronous circuits. Okay now, I hope you are clear with this. Now let's move on to the third question, that is what they have given. We have to construct see what they have given, that is A B C D and 0 1 3 4 11 12 13 14 15 using 4 to 1, that is, and 4 is to 1 multiplexer and 8 is to 1 multiplexer. Okay now you can use that two methods to construct 18 is to 16 is to 1, and next I have constructed is 8 is to 1. Okay now see, most of the time they have not asked 4, they have asked 16. Now in order to you have to get 16 inputs, right? See what you will take 1 2 3 4 5 6 7 8, and here also 8. How the you will can remember the truth table is, first ಏನು ಮಾಡ್ತೀರಾ ಅಂತಂದರೆ 8 ಝೀರೋಸ್ ಬರ್ಕೊತೀರ, ಮತ್ತು 8 ಇನ್ಪುಟ್ಸ್ 1 ಬರ್ಕೊತೀರ. ನೆಕ್ಸ್ಟು ಫಸ್ಟು 8 0 8 1, ನೆಕ್ಸ್ಟು 4 0 4 1 4 0 4 1 4 0 4 1 4 0 4 1 ಅದೇ ಇನ್ಪುಟ್ಟು. ಮತ್ತೆ 2 0 2 1 2 0 2 1 2 0 2 1 2 0 2 1, ಮತ್ತೆ ಇಲ್ಲಿ 0 1 0 1 0 1 0 1. The same way you will take, first is 8 zeros, next is 4 times, next is 0 0, next is 1 time. That is the formula you will be, this is 8 times. Okay 3 6 8. Okay, this is the formula for the input you will be following. If you are feeling difficult to remember the truth table, this is the one method or ಇದನ್ನು ನೀವು ನೆನ್ಪಿಟ್ಕೊಬೋದು. ಈಗ ಇದನ್ನು ಹೆಂಗೆ ಬರ್ಕೊಂಡಿರೋದು 1 ಮತ್ತು ಇದು y is nothing but the output. ಇಟ್ ಈಸ್ ಏನು ಔಟ್ಪುಟ್. ಈ ಔಟ್ಪುಟ್ಟಲ್ಲಿ ನಮಗೆ 0 1 3 ಎಲ್ಲ ಕೊಟ್ಟಿದ್ದಾರಲ್ಲ, ಇದನ್ನು 0 1 2 3 ಆ ಥರ ಎಲ್ಲ ನೇಮ್ ಮಾಡಿಕೊಂಡು okay fine. Now see, you can follow this 8 4 2 1 rule. 8 4 2 1 rule. Now where you will get 0, here all the 0 is there, you will get 0. Now 1 1 is there, you will write it 1. 3 you have to get means 2, and this is something has gone wrong here. Wait a minute, I'll be checking it. Here 1 2 3 4 5 6, and here it is 11 12 13 8 2 becomes 14, and next is 15 has not been given. Now zero, 1, sorry guys, I have missed the question here. The question is they have given as 1 6 Okay, I'll be cutting this, I'll be writing here. Okay, let me erase this and all. Sorry for the time disruption. I'll discuss now. Okay, the question was had become a bit mistake. Okay, the question is 0 1 6 7 8 9 10 11 12 and 14. Okay, this is the question they have given. Now if you want to discuss this, how you will write the truth table is that next you will be seeing the, see here the same way as I said 8421 rule also you can take, or you can consider that 0 1 2 3 and all like that also you can do, and you'll be putting for 0, next is 1, next is here it is 6, that is 4 plus 2 is 6 7, and next is for 8 9 10 12, and for 15 it is not coming, and for 13 also the same way you will be calculating this. And how you will write this mux is, that is for the 16 is to 1. Next you will be seeing, see um, the here you will be adding all the inputs, that is 0 to 15, right? How many inputs you will have? 0 to 15. Where the number it is been given, you will be having one line, that is inputs will be a b c d as it, and this will be output, that is y, and you will be carried out the input, that is from where it is 1 it will be from here, the input will be 0 here as you can see, and the input will be 1 here. Okay, the same way you will draw this mux. Next is you can see the same way you will draw for 8 is to 1. For 8 is to 1, the change you will do here is you will consider it as 0, you will consider it as 1, you can consider it as 2, you can consider it as 3. The same way you will write the truth table, and the same way you will get this mux. Okay, I hope the same method you will follow. Next is about the different modeling style that is used in Verilog code. Okay, with an example we will write it. There are basically 4, that is behavioral, ಒಂದು behavioral, data flow, gate level ಮತ್ತು structural. ಓಕೆನಾ, ಈ ಅಷ್ಟು ತಗೊಂಡ್ರೆ ನಾವು ಬಿಹೇವಿಯರಲ್ ಡಿಸ್ಕಸ್ ಮಾಡೋಣ. ಬಿಹೇವಿಯರಲ್ ಅಂತಂದರೆ ಏನು, ವಾಟ್ ದ ಸರ್ಕ್ಯೂಟ್ ಡಸ್. ಈಗ ಒಂದು ಸರ್ಕ್ಯೂಟ್ ಇದೆ ಅಂತಂದರೆ ಈ ಸರ್ಕ್ಯೂಟ್ ಏನು ಮಾಡುತ್ತೆ ಅದನ್ನು ಡಿಸ್ಕಸ್ ಮಾಡ್ತೀವಿ, ನಾಟ್ ಹೌ ಇಟ್ ಈಸ್ ಇಂಪ್ಲಿಮೆಂಟೆಡ್. ಇದು ಹೆಂಗೆ ಇಂಪ್ಲಿಮೆಂಟ್ ಆಗಿದೆ ಅನ್ನೋದ್ರ ಬದಲು ಇದು ಹೆಂಗೆ ವರ್ಕ್ ಆಗುತ್ತೆ ಅನ್ನೋದ್ರ ಮೇಲೆ ಬೇಸಿಕಾಗಿ ಫೋಕಸ್ ಮಾಡಿ. ಇಟ್ಸ್ ಪ್ರೊಸೀಜರಲ್ ಬ್ಲಾಕ್ಸ್, ಇಟ್ಸ್ ಆಲ್ವೇಸ್ ಇನಿಷಿಯಲ್ ಆ್ಯಂಡ್ ಆಲ್ವೇಸ್ ಇಟ್ ಈಸ್ ಅಲ್ಗಾರಿದಮಿಕ್ ಆ್ಯಂಡ್ ಕಂಟ್ರೋಲ್ ಲಾಜಿಕ್ ಟು ಇನ್ಪುಟ್ ಆ್ಯಂಡ್ ಗೇಟ್ you know, right? This AND gate if you take, you will have input a b and output will be something red y, something you will consider. Next is about the always at a or b, that is you will consider always at a or b, and next you will take y is equal to a and b. Y you will take it as a and b. See now how you are taking is, the two input AND gate, that is two input a b you are taking, in output you are giving as y, the same way you are taking AND a or b. Okay, the same way you will see for data, that is continuous assignments will be there. There is a flow of data, and the flow of data between input output boolean expression in the same way you will consider it will be what, and the expression will be written as what, and here. And next again you will take this input, it is primitive logic methods you gates use ಮಾಡ್ತೀವಿ, and or not ಇದೆಲ್ಲ ಏನೋ ಲಾಜಿಕ್ ಗೇಟ್ಸ್. ಇಟ್ ಈಸ್ ಕ್ಲೋಸ್ಡ್ ಹಾರ್ಡ್ವೇರ್ ಇಂಪ್ಲಿಮೆಂಟೇಷನ್ನ ಫೋಕಸ್ ಮಾಡಿ ಇಲ್ಲಿ ಮಾಡ್ಯೂಲ್ ಆ್ಯಂಡ್ ಗೇಟ್ ಎ ಬಿ ವೈ ತೊಗೊಂಡು, ದಟ್ ಇಸ್ ಇನ್ಪುಟ್ ಎ ಬಿ ಇನ್ಪುಟ್ ಔಟ್ಪುಟ್ ವೈ, ಎ ಬಿ ವೈ ಎ ಬಿ ತೊಗೊಂಡು ಎಂಡ್ ಮಾಡ್ಯೂಲ್. ದ ಎಂಡ್ ಮಾಡ್ಯೂಲ್ ಇಸ್ ಕಂಪಲ್ಸರಿ ಫಾರ್ ಆಲ್. ಅದರಲ್ಲಿ ಏನಿರುತ್ತೆ, ಇಂಟರ್ ಕನೆಕ್ಷನ್ ಆಫ್ ಮಾಡ್ಯೂಲ್ಸ್ ಅಂದರೆ ಮಧ್ಯ ಅಂದರೆ ವಿತಿನ್ ದೆಮ್ ಸೆಲ್ಫ್ ಅಂತ ಹೇಳ್ತಾರಲ್ಲ ಆ ಥರ ಇರುತ್ತೆ. It is similar to drawing a block diagram. That is when you draw a block diagram, right? When you see one Verilog modules and all, you draw. That is how you are using. Here you can use and, not, and NAND also. NAND. Here use and, here it is NAND, and here it is not. Any method you can use. Now next of the important question is, you have to see what is how to design a BCD, okay, to access 3 code converter. Access 3 ಕೋಡ್ ಕನ್ವರ್ಟರ್. ಈಗ ನಾವು ಏನಂತಂದರೆ, ಈಗ ಒಂದು BCD BCD ಟು XS3 ಕೋಡ್ ಕನ್ವರ್ಟರ್ನ ಡಿಸೈನ್ ಮಾಡಬೇಕು. ಅದು ಹೆಂಗೆ ಅಂತಂದರೆ, ಫಸ್ಟು ನಾವು ಏನೇ ಇದ್ದರೂ ನಿಮಗೆ DDCO ಸಬ್ಜೆಕ್ಟಲ್ಲಿ ನೀವು ಹೇಗೆ ಆನ್ಸರ್ ಪೇಪರ್ ಮಾಡಬೇಕಂದ್ರೆ, ಫಸ್ಟ್ ಏನಾದ್ರು ಕ್ವೆಶನ್ ಲೈಕ್ ನ್ಯೂಮರಿಕಲ್ ಆರ್ ಸಮಥಿಂಗ್ ಲೈಕ್ ದ್ಯಾಟ್ ಇದ್ದರೆ, ಈಗ ನೀವು ಟ್ರೂತ್ ಟೇಬಲ್ ಬರಿದ್ದು ಆಮೇಲೆ ನೀವು ಎಕ್ಸ್ಪ್ಲನೇಷನ್. ಈಗ ಈ ಟ್ರೂತ್ ಟೇಬಲ್ ಹೆಂಗೆ ಬಂತು ಅಂತ, ಇವಾಗ ನಾರ್ಮಲ್ ಟ್ರೂತ್ ಟೇಬಲ್ ಸಚ್ ಆಸ್ ಆ್ಯಂಡ್ ಆರ್ ನಾಟ್ ಇದೆಲ್ಲ ಓಕೆ ಫೈನ್. ಈಗ ನೀವು ಈ ಟ್ರೂತ್ ಟೇಬಲ್ ಹಂಗೆ ಬಂದಿಲ್ಲ, ಸೊ ದ್ಯಾಟ್ ಈಸ್ ಹೌ ಯು ವಿಲ್ ಯೂಸ್. ಓಕೆ, BCD ಬೈನರಿ ಕೋಡ್ ಡೆಸಿಮಲ್, ದ್ಯಾಟ್ ಈಸ್ ಕೋಡೆಡ್ ಡೆಸಿಮಲ್ ವಿಲ್ ಬಿ ಫಾರ್ಮ್ ಫ್ರಮ್ XS3 ಕೋಡ್ ಕನ್ವರ್ಟರ್. ಈಗ ನೀವು ಸೇಮ್ ವೇ ಐ ಸೆಡ್ ಯು ವಿಲ್ ಟೇಕ್ 16 inputs here, you will take 16 inputs and you will get 16 outputs, and all will be 0, and here you will get only, you should get 3, right? 8421 rule, that is 3. And the same way you will be getting here as next is about the 0 0 0 0 0 0 0 1. Next is what? 0 0 1 0 0 0 1 1. Next is 0 1 0 0. Next is what? 0 1 0 1. Next is what? 0 1 1 0. The same way you will be adding, as I said, the same way. That is for decimal 0. Okay, decimal 0 will be having what? 0 0 1 1. Okay, now for decimal 1 it will be having what? That is 0 1 0 0. That is, you should get XS3 output. Okay, now the same way, that is 1 0 1 0. If you get the last 1 0 1 0, if you take, that will be 1 1 1 1. Okay, that will be don't care condition. As you saw in the previous module, what you will be doing while solving this, you will be putting as X. That is how this similar. And next, if you see the diagram, that is, you have taken A B C D as input, and here you have given, if it is bubble, it is NAND. Okay, and you have and next is about the, you have constructed a expression for it, the same truth table you have used, and here you can see these are the 4 types of expressions that are being occurred here, that is map. Okay, now you have to construct 8:1 using 2:1 marks. Okay, you have to construct 8:1 marks using 2:1. Okay, the same way how you will do 8:1, right? So how much you will take input? That means you should get 2, that is 2 power 3. You will take it as 8 inputs, 2 4 6 and 8. That is, you will name it as I0 to I7. Okay, I0 to I7 andre 2 input tagondu, again the same way you will add it as 2:1. This will be 1 2:1 marks, 2:1 marks, 2:1 marks. Then you will add that, and again you will be having 2:1, again you will be having 1. This will be output. Next, the same way you have to draw the truth table. Here you will get 8, right? So you will draw what? There it was 8 zeros, 4 ones, and like this it was. But here it will be 4, again 0 0 1 1 0 1 0 1. How you will draw this? See, first is what? The output is I0, I1, I2. That is how you will write the outputs. This is all about the question constructing 8:1 marks using 2:1. You can elaborate it bit so that you will get a good theory concepts along to write in the exam suddenly. Next is about the SR latch example. ನೀವು ಇದನ್ನ ನೋಡ್ಕೊಬೋದು, ಬಟ್ ಐ ವಿಲ್ ಎಕ್ಸ್ಪ್ಲೇನ್. ಓಕೆ, ವೆನ್ S is equal to, first you should remember this truth table. Okay, when S is equal to 1, R is equal to 0, it will be what? 1 and 0. This is nothing but the complement. That is, Q will be what it will be there, that complement you will do. That is, if it is 0 1 1 0, that is 0 means 1 you will do. That is the same logic you will be carrying out here. If it is 1 0, it is 1, and if it is 1 1, see here, if it is, see, you can see that the input is 1 0 means it is 1 0, and next is 0 0 1 0 0 1 0 1 0 0 0 1 1 1. This is the forbidden state. We will say that it is forbidden state. ಇದನ್ನ forbidden state ಅಂತೀವಿ. S 0 ಮತ್ತೆ R 1 ಆದರೆ after S is equal to 1 ಮತ್ತೆ R is equal to 0. This is the truth table you have to remember for the SR latch, and you can write the what is the explanation of truth table. And here you have constructed a NOR gate. That is, see, NOR or is nothing but what? This is nor, or, and if you add a bubble to it, it is nor. And the same way you will carry out, that is s and r, you will give the inputs, and you will get q and q dash, and you will be interconnecting with them, and this you will be connecting with this. This is about the SR latch, that is using NOR gate. You can construct it also using the NAND gate, that also it is same, but you are using true cross coupled NAND gate. That is cross coupled, right? It is connected, interconnected. This is connected to between this, and this is connected to the down NAND gate. That is called two ಕ್ರಾಸ್ ಕಪಲ್ ನ್ಯಾಂಡ್ ಗೇಟ್. ಐ ಹೋಪ್ ಯು ಆರ್ ಗೆಟ್ಟಿಂಗ್, ಅರ್ಥ ಆಗ್ತಿದೆ ಅಂತ ಅನ್ಕೊತೀನಿ. ಈಗ ನೀವು ಮತ್ತೆ ಒನ್ ಇದ್ದಾಗ ಔಟ್ಪುಟ್ ಝೀರೋ ಆಗುತ್ತೆ, ಮತ್ತೆ ಏನಾಗುತ್ತೆ, ಒನ್ಗೆ ಹೋಗುತ್ತೆ, ಮತ್ತೆ ಅದು ಕಾನ್ಸ್ಟೆಂಟಾಗಿ ಉಳಿದು ಹಿಂಗೆ ರಿಪೀಟ್ ಆಗ್ತಿರುತ್ತೆ. ದ ಸೇಮ್ ವೇ ಇಟ್ ವಿಲ್ ಬಿ ರಿಪೀಟಿಂಗ್. ಹಿಯರ್ ಏನಾಗುತ್ತೆ, ಝೀರೋ ಇದ್ದರೆ ಒನ್ ಆಗುತ್ತೆ, ಮತ್ತೆ ಒನ್ ಡೌನ್ ಬರುತ್ತೆ, ಮತ್ತೆ ಹಿಂಗೆ ರಿಪೀಟ್ ಆಗ್ತಿರುತ್ತೆ. ದ ಸೇಮ್ ವೇ ಯು ವಿಲ್ ಬಿ ರೈಟಿಂಗ್ ಹಿಯರ್. ದಟ್ ಇಸ್ ಫಾರ್ ಎಸ್ ಎನ್ ಆರ್. ಇದ್ರದ್ದು ನೀವು ಅಪ್ಲಿಕೇಶನ್ ಆಫ್ ಎಸ್ ಆರ್ ಲ್ಯಾಚ್ ಇನ್ ಸ್ವಿಚ್ ಡಿಬೌನ್ಸಿಂಗ್ ನೋಡಿದ್ರೆ, ಇಟ್ ಈಸ್ ಯೂಸ್ಡ್ ಯೂಸಿಂಗ್ ನ್ಯಾಂಡ್ ಗೇಟ್ಸ್. ನಾವು ಯೂಸಿಂಗ್ ನ್ಯಾಂಡ್ ಮತ್ತು ನಾರ್ ಎರಡೂ ಮಾಡಿದ್ವಿ ಅಲ್ಲ, ಇದು ನ್ಯಾಂಡ್ ಗೇಟ್ಸಿಂದ ಕಾಮನ್ಲಿ ಯೂಸ್ ಫಾರ್ ಸ್ವಿಚ್ ಡಿಬೌನ್ಸಿಂಗ್. ಏನಕ್ಕೆ ಅಂತಂದರೆ, ಅನ್ವಾಂಟೆಡ್, ದಟ್ ಈಸ್ ಮಲ್ಟಿಪಲ್ ಟ್ರಾನ್ಸಿಷನ್ ಕಾಸ್ಡ್ ಬೈ ಮೆಕ್ಯಾನಿಕ್ contact bounce in switches, that is mechanical contact bounce in switches will be happening, right? To avoid that, it will be happening. And next is when the switch is pressed or released. When you have a one switch, it is pressed, or if you release it, the latch ensures that the output state only remains stable. Okay, the output state should remain stable, so you'll use the SR latch there. I hope you understood. The next question is about the edge triggered D flip flop. ಇದು ಏನಂತಂದರೆ, ಎಡ್ಜ್ ಟ್ರಿಗರ್ಡ್ ಡಿ ಫ್ಲಿಪ್ ಫ್ಲಾಪ್, ನೀವು ಲ್ಯಾಚಸ್ ಮತ್ತು ಫ್ಲಿಪ್ ಫ್ಲಾಪಿನ ಡಿಫ್ರೆನ್ಸ್ ಎಲ್ಲ ನೋಡಿದ್ರಿ. ಇದು ಸೇಮ್, ಇದರಲ್ಲಿ ಎರಡು ಬರುತ್ತೆ, ನೆಗೆಟಿವ್ ಮತ್ತು ಪಾಸಿಟಿವ್. ಇದರಲ್ಲಿ ನೀವು ಮಾಸ್ಟರ್ ಸ್ಲೇವ್, ಇದನ್ನು ಹೇಳ್ತೀನಿ ನಾನು ಬ್ರೀಫಾಗಿ, ಇದನ್ನು ಡಯಾಗ್ರಾಮ್ ಹಾಕಿದ್ದೀನಿ, ಯು ಕ್ಯಾನ್ ರೈಟ್ ಅ ಬಿಟ್ ಥಿಯರಿ. ಓಕೆ, ನಾವು ನೆಕ್ಸ್ಟ್ ಇಸ್ ಅಬೌಟ್ ದ edge trigger. That means output Q changes only at a clock diagram, that is edge, not only during entire clock level. As you studied, that is about the level and the edges. Here it does not change at the edges, here it will change at the address, and not at the clock level. As you saw, it is edge and between the clock level. Okay, next is about the, if it is 1 to 0, it is negative edge, if it is 0 to 1, it is positive edge. See, here you can see that is positive edges being given, and the one changes here, you will add this bubble. Next is master slave, that is, this is like a master, this is like a slave. You will add D latch, and there will be two inputs, and here you will be given what, two inputs, that is D and clock, and you will be adding one NAND gate, and you will be giving input, and you will get the Q as the output. Here the Y will be the output for the master, and for slave it will be Q. I hope you got this. You can see all these working principles. What are the advantages? It only reacts to clock edges. Here it has multiple changes. It prevents uses in registers, counters, and memory circuits and all. Now next, let's discuss about the ಡಿಕೋಡರ್. ಡಿಕೋಡರ್ ಅಂದರೆ ಏನಂತಂದರೆ, ಇಟ್ ಈಸ್ ನಥಿಂಗ್ ಬಟ್ ಅ ಕಾಂಬಿನೇಷನಲ್ ಸರ್ಕ್ಯೂಟ್ಸ್. ಏನಂತಂದರೆ, ಇಟ್ ಕನ್ವರ್ಟ್ಸ್ ಬೈನರಿ ಇನ್ಫಾರ್ಮೇಷನ್ ಏನಿರುತ್ತಲ್ಲ, ಅದನ್ನು ನಮಗೆ ಮ್ಯಾಕ್ಸಿಮಮ್ 2n ಇನ್ಪುಟ್ಸ್ ಲೈನಿಗೆ ಕನ್ವರ್ಟ್ ಮಾಡೋದನ್ನ ನಾವು ಡಿಕೋಡರ್ ಅಂತ ಕರಿತೀವಿ. ಇದು n ಇನ್ಪುಟ್ಸ್ ನೀವು ತೊಗೊಂಡ್ರೆ, ಇಟ್ ಹ್ಯಾಸ್ 2n ಔಟ್ಪುಟ್ಸ್. ಓಕೆನಾ, ಈಗ ನೀವು ನೋಡ್ಬೋದು, ಎಕ್ಸ್ ಮತ್ತು ವೈ ಮತ್ತು ಝೆಡ್ ಯೂಸಿಂಗ್ ನ್ಯಾಂಡ್ ಗೇಟ್ಸ್ ತೊಗೊಂಡಾಗ ನೀವು ಒಂದು ಇಲ್ಲೇ ಬರಿಬೋದಿತ್ತು, ಬಟ್ ನಿಮಗೆ ಕನ್ಫ್ಯೂಸ್ ಆಗುತ್ತೆ ಅಂತ ಅವ್ರು ಹಿಂಗೆ ಕೊಟ್ಟಿದ್ದಾರೆ ಡಯಾಗ್ರಾಮ್ನ. ಮತ್ತು ಅದು ಎಕ್ಸ್ ಡ್ಯಾಶ್, ವೈ ಡ್ಯಾಶ್, ಝೆಡ್ ಡ್ಯಾಶ್ ಆಗುತ್ತೆ. ಅಂದರೆ ನೀವು ಔಟ್ಪುಟ್ ವಿಲ್ ಬಿ ವಾಟ್, ಎಕ್ಸ್ ಡ್ಯಾಶ್, ರೈಟ್, ಯೂಸಿಂಗ್ ದ್ಯಾಟ್. ಐ ಹೋಪ್ ಯು ಗಾಟ್ ದ್ಯಾಟ್. ನೆಕ್ಸ್ಟ್ ಇಸ್ ಇನ್ಪುಟ್ ಎಕ್ಸ್ ವೈ ಝೆಡ್ ತೊಗೊಂಡು D0 to D7, ದಟ್ ಇಸ್ D0 to D7 ಔಟ್ಪುಟ್ಸ್ ತೊಗೊಂಡ್ರೆ ಹೆಂಗೆ ಅಂತಂದರೆ, ಒನ್ ಅಟ್ ಎ ಟೈಮ್ ಬೇಸ್ಡ್ ಆನ್ ದ ಇನ್ಪುಟ್ ವರ್ಕ್ ಆಗುತ್ತೆ. ಎಕ್ಸ್ 0, ವೈ 0, ಝೆಡ್ 0 ಇದ್ದರೆ 1, ದಟ್ ಇಸ್ D0 is 1. ನೆಕ್ಸ್ಟ್ 0 0 1 ಇದ್ದರೆ 1, D1, ದಟ್ ಈಸ್ ದ ಸೇಮ್ ವೇ, ದಟ್ ಈಸ್ ಎಕ್ಸ್ 0, ವೈ 1, ಝೆಡ್ 1 ಇದ್ದರೆ ಡಿ ಏನಾಗುತ್ತೆ, 0 1 1 ಅಲ್ವಾ. 0 1 1 ಇದ್ದಾಗ ಏನಾಗುತ್ತೆ ನಿಮಗೆ, x dash y z it should be. That means it will be D3, as you can see here. I hope you know this concept. If it is dash means it is 0. If it is y z means it is 1. That means what, 0 1 should be there. That means x bar y z should be there. That is how you observe this table. That will get it, you will get it in this. That will be equal to 1. The same way you can write it here. Next is about the explain JK, SR, T and D. That is almost SR and D I have answered. Now you can see about the SR and JK and D flip flop. I am just briefing it out. I am not just telling all the concepts because you guys don't have much time, because second is only your exam and this subject is on fourth, and I cannot waste your time by saying all the concepts, and you will not be having time because you have to prepare for maths as well and OS as well, as you have only 1 day gap. So you try to cover most of the syllabus with perfection. Okay, I hope by seeing this video you will get all the second module concepts. If you have any doubts, you can let me know in the comment box. The same PDF you can get it by DMing me on Instagram. I'll mention my Instagram account on my description box. Thank you for watching the video. Make sure to like, share, comment and subscribe to my YouTube channel if you have not done yet. And thank you for watching the video. Next I'll be uploading this third module tomorrow. For that, stay tuned, and until then, bye bye.